As we discussed in the last video, we mentioned that a number of factors can affect equilibrium. One being temperature, which we discussed in the last video, and today's one that we're going to discuss is concentration. Again, we're referring to Le Chatelier's principle. So remember, that is when a reaction undergoes a stress, that could be an increase in temperature, increase in reactants, or that increase in pressure or volume, it's going to act in such a way as to counteract that change. So the change that we're going to look at today is concentration. So hopefully by the end of this video you will be able to explain the effect of increasing or decreasing the concentration on that chemical system that is already at equilibrium, and be able to predict the effect considering the reverse and forward reactions. So let's look at our equation here. Let's just take an example which you will do in your depth study. Let's consider this reaction. So we've got iron 3+ ions in solution, and that's colourless. And then we've got our thiocyanate ions given by the formula there of SCN, and they're also colourless. But when we added our two solutions together, we got that blood red colour, often used as our fake blood in our movies. So that's our standard reaction at equilibrium. What do you think would happen if I was to add some iron chloride solution to that reaction? So looking at our equation there, if I am adding some ions to that reaction, we are going to get our reaction shift to the right and the formation of the iron thiocyanate ions there, and that colour is indicated with that blood red colour. So that blood red colour is going to intensify, and that can be explained in the same way as with our temperature. As Le Chatelier said, if an increase in concentration happens, the system is going to try and partially counteract that change. So if I increase my production here of these ions, an increase in production is going to drive the reaction this way and increase the formation of those iron thiocyanate ions on the right hand side. So this is what we've already discussed. The product will intensify that colour. So what would happen if we added thiocyanate ions in another form? And again, the increase in thiocyanate is going to drive the reaction to the right. So let's look at this graph, which is another way that we can represent what's happening in that equation, or in that reaction rather. And we can see over here, here are our two products. We have got, as the reaction proceeds, we've got a decrease in the concentration here of our iron ions, and again in our thiocyanate ions. And as that's happening, as you would expect, we have an increase here in our products. At this point here, we have an increase in our concentration of our iron ions because we added some of those iron 3+. So of course we expect that to rise, and it will then gradually decrease. Here we haven't had an increase in the concentration of our thiocyanate, so there is no increase there, and as the reaction proceeds, it's being used up, so it, as you would expect, would also decrease. What are these things here meaning? These X arrows, you can see again in our mole ratio, it's 1 mole of reactant, 1 mole of thiocyanate reactant is producing 1 mole of the iron thiocyanate. So all of those are an equal decrease and an equal increase. So at this point here, again, we can see there is that increase in production of that thiocyanate due to the increase in these iron ions to the system. Again, another really good table to have that summarizes what's taking place. Here we can see an increase and a decrease in our change in concentration, what it will do to the reactants, and what it will do to the products. And again, the position of equilibrium, that's just saying where is it moving? Is it moving to the left or is it moving to the right? And again, this equilibrium constant that we will address at a later time.